Hello and welcome to the session Deep Learning IDE on top of Apache NetBeans. My name is Zoran Sevarac and I'm coming from DeepNetts, a startup building deep learning development platform in Java that tries to simplify deep learning for non-experts. I'm a Java champion and member of the Apache NetBeans project management committee. So the main idea how we are making deep learning easy for non-experts is to put deep learning inside the IDE. So all the procedures and steps that you have to take while building a deep learning model are available within Wizard's project window and visual tools that are well known to software developers and fall into something that we know as a common IDE workflow. The entire platform is built on top of Apache NetBeans, and as a proof of concept, one of our users is 14 years old boy who learned Java during a lockdown, and after only 2 months he was able also to use DeepNetts to create a deep learning model for his Java-based game. You can read the full story on our blog following the link on the right. And also I would like to say that the entire platform is available under free development license. So to get down to the point and show you how it is being done in practice, I will show you a simple image classifier convolutional network, which is a very basic deep learning model that will be able to recognize Duke mascot images. So it will be able to tell us whether the image on the image contains Duke logo or it does not. As you can see, there are two groups of images, one with Dukes and the other one which are negative examples. The basic principle of how deep learning works is to give to a model a set of examples and to initiate the training procedure. By the way, entire video is available on the link below. So this is how this main screen of a DeepNetts application looks like, and in order to build this image classifier based on a deep learning model, we are going to run the new project wizard. We start with DeepNetts project. We'll say it's a Duke project, and as a first step, wizard asks us what do we want to do. We say we want to classify images, and the other type of machine learning tasks which are available is also to classify data or to predict value. The next step is to input how many image categories we have. Here we have only 2 image categories, Duke and non-Duke, which is well known as a binary classification problem, so we select the options with 2 categories. Next step is to select image, to select directory which contains training images, and we have prepared this kind of training set here, the Duke set, and it automatically finds this index file and labels file which contain just a path to different images. The next step, we select the size because of the images, because all images have to be scaled to the same size, and in this case all the images are prepared already for the size 64 times 64 pixels, but in the case they are not, you can choose different options to resize these images. So this is a good example of how this wizard guides you in preparing data and performing typical steps which are considered to be a best practice in preparing data for deep learning, and some of these steps might not be familiar to software developers which don't have experience with this type of task. Also, there are additional pre-processing options which help learning algorithm to learn better. Now, the next step is specifying neural network architecture, and here you can see some of the parameters of the neural network are already pre-configured from the data entered in previous steps. For example, the dimensions of the input layer, which corresponds to image dimensions. And since it is a classification problem, the loss function is configured, and also number of neurons in output layer and the output activation functions. So this is the way how we provide predefined configuration settings for specific tasks, so users don't have to know all the details about the model they are trying to build a task to solve. So we enter here the basic configuration for the convolutional network. This convolutional layer acts as a feature detector, so it can learn to recognize features in image pixel patterns, so-called. And we'll put just 3 channels, one's a very small network, and let's put this 32 neurons in a fully connected layer. Now the next step is to configure training and testing data. For this step, you don't even have to, you can use provided default, which means splitting training and test set into 2 parts, 70% for training and 30% for testing. This is done because we want to see how will our model work with the data it has not seen during the training. And as well as in the previous step, the reasonable defaults are provided. The next step is very important, and you're given different parameters to tune the learning procedure, and the provided values are like a default, and if you just click finish, you will get the basic settings for building a deep learning model. Now all of these settings will be very easy to edit and pre-configure later in the process, and the good thing is that when you run some build some model for data the first time, you don't have to understand and know all the details about configuring this. Just run the wizard and you'll get the entire configuration that you needs to run, like this initial training. Now what you see here now is so-called visual machine learning workflow, which has been generated with this wizard, and it includes all the steps for running the training, and you can easily access all the configuration settings that were entered in the wizard. For example, for dataset, if we click dataset, it opens the dataset file, which are given as a properties file. You can see something that is very familiar to Java developers, and all the settings entered in wizard are here. Next, for neural network architecture, it is specified as a JSON file, and you can very easily change layer types or image size or anything else. In addition, there is a visual neural network architecture builder in which you can visually inspect the network architecture and see the settings for each of the individual layers here in the properties table. That makes it very easy to later change some of these settings and try out different configuration, which is very common procedure while building a deep learning model. And this box here represents the settings for the training procedure, and you can see here we have, for example, settings for the maximum error, since the deep learning procedure consists of lowering the prediction error for the given training set, and it is being performed iteratively in so-called epochs, and here we have specified also the maximum number of epochs. Now when you have all these things configured, there's one more thing. This is a model evaluation, which corresponds to testing model. Once you build the model, you want to see how it performs with the unknown data, the data that it has not seen, which was data that was not used for training, and it calculates classification metrics, which is a set of values which tell us how good is network at classifying the images. Now this training file here is the key for running a training, and in order to run it, you just hit this play button, right, in the toolbar, like you're used to do in your software development projects. And let's check this option for visualization so we can visually inspect the training procedure. Now at the moment this tool supports DeepNetts deep learning framework, but there is ongoing development to support also TensorFlow, and there will be option also to run training remotely on the cloud. At the moment you are able to run trainings on your local machine. Next, when we start training, you will see the log window will display what it is doing, and here we have nice visualization, as you can see, how the network is being fed with images, what happens in the input layer, and how it applies different convolutional filters and scales down in images, and how it is being propagated through the entire network to the output. So this one neuron is output, and it is saying when it is red it has high activation, then it predicts that the image is Duke, and when it is not, it means that it is not a Duke. Here we have information about the training. As you can see, the initial error was 0.69, and after just one epoch or one pass through the entire data set, the network is lowered to 0.23, and the training accuracy is 0.97, which is 97%. As you can see, since this is a very small data set and small network, it is being trained very quickly, and it shows you how you can quickly train deep learning model for recognizing like a smaller number of training images. Now we can also speed things up. This is intentionally slowed down. It will run very fast, and here we are going to show you also this training graph, which shows you how the network is lowering down. The value of the loss function is going down during the training iteration, and how the accuracy is growing up. And after the training has been completed, the testing or evaluation procedure will automatically be performed, and it will give you some numbers down here, which tells you how good network is at predicting Duke images. As you can see, accuracy for the training set was 0.99, and what is common is that accuracy with test set is a bit lower, which is 0.96. Now there are also other information, for example precision, which tells us how often is classifier correct when it gives positive prediction. One nice thing is that besides giving you all these numbers, DeepNetts tell you what each of these numbers means. The other metric, for example, is recall, which tells us when it is actually positive class, when it is actually a Duke image, how often the classifier gives positive prediction. And metric which is kind of a balance between precision and recall is F-score, which is harmonic average of precision and recall. Now all these values are being extracted for something that is called confusion matrix, and as you can see, this diagonal, most of these images, these are true negatives and true positives, are being guessed correctly. Only 7 images are not guessed correctly. So now, if you want to see what images are not guessed correctly, we have a tool to do that. And I forgot to mention, the trained network is being generated here in a folder named trained networks, and this is this DNet file. And if we want to create a jar file that we can use in our application, we just right click that DNet file and say create jar, and it will automatically generate jar with our deep learning model. And entire training procedure is available in this training log file, which tells us how the model is being built and give us the main information about the accuracy for a specific test set. Now, if you want to, for example, inspect the images that have been used for training, we use this image dataset explorer, and when we select some specific class, we can see all these images of dukes that were used to train the network. If you want to see the negative images, these are blocks of color and color rectangles, which we use just to make sure that the classifier is not reacting just to any color. Now we have a tool to test this entire train network for the image set. We select the network to train, so it says select network, and we select dataset, and then we say test all images. And now, as you can see, you get a list of images from the data that has been used for training, and for each image we say what is the actual class of the image, this negative, and what the class is recognized, this is negative, and what was the output of the network. If the output of the network is higher than 0.5, then this network has recognized input image as a duke. You can see this is a duke, even if it is around half image, it is a duke. And this green rectangle is not a duke. This is a duke, and this is a duke. Now, if you want to see what are the mistakes, what image were not recognized as duke, we click here only false prediction. And we can see that some of these images, this all white, was recognized as a duke, which is not good. You can see this was not also recognized as duke, and these are one that we have to pay attention to and change some parameters for the network and train it better. So this is how you can, as you can see, just running one wizard and taking a few tools, you can build and evaluate your deep learning model, and you have it ready as a serialized Java object or even as a jar file. Now, once you have deep learning model, what do you do with it? Well, you can load it in your Java application like this. This is an example. How do you load convolutional neural network? Here, you just use create from file method from the file IO utility, and then you create image classifier, and then invoke classify method. Now, this image classifier interface and convolutional image classifier, they come from the visual recognition API, which is the standard Java API for visual recognition tasks, and DeepNetts is community edition of DeepNetts is being used as a reference implementation for this API. It is a machine learning based Java API for visual recognition tasks. So you can see in only 2 lines you perform recognition of image, load model, and then invoke classify model, classify method, and feed it with some image. You can see we can run it here. You get result as a map that contains corresponding probability that image belongs into the category duke is 0.99, as you can see. You see this line here. The other option is to use training procedures directly from the Java code, so you can do also that, and this is an example how this can be done without this user interface. In that case, you need to know more details, and for some advanced options you need to understand more of the machine learning and deep learning workflow, but it is possible to do it if you prefer it that way. However, it is much easier to build the model using this graphical user interface. So on this GitHub repository, you have examples that you have just seen, and you can download DeepNetts and try it on your own. So one of the questions we very often get is when to use DeepNetts, when there are very advanced deep learning frameworks like TensorFlow, deep learning Foojay and so on, which support GPUs and distributed training and so on. But DeepNetts is pure Java and it supports most commonly used deep learning algorithms. So it is very simple and easy to integrate within existing products. It is highly portable. It does not have dependencies on all the native libraries, and it is very friendly and easy to use. I think that is one of the most important features. It is much easier to use and understand by an average Java developer than any other framework out there. So I would say that you should consider using DeepNetts when you want to integrate deep learning into existing software products in order to make it smarter. And when you don't have huge amounts of data, when you have a smaller number of specific objects to recognize, for example, then it is difficult for you, or maybe you don't need to gather the large amount of training data, and you don't require high level of generalization to be able to deal with all different variations of that input. In that case, smaller models with smaller data set, DeepNetts can learn very well and provide even higher accuracy than working with huge models with big deep learning frameworks. Also, when you have hardware constraints, like in all the edge AI use cases, limited CPU and memory, and you don't have a specialized hardware like GPUs, then DeepNetts can be an ideal solution. And the main advantages for using DeepNetts is that for these kind of problems, you get a better accuracy with less data. You have lower CPU and memory requirements, and it is highly portable and can be integrated on every Java-enabled device, which makes it easier to build, run, and maintain. In order to get started, you can go to DeepNetts/getting started, and you can follow the instruction to download the setup, and there is a good documentation and also some examples on our blog how to do parking lot occupancy detection, how to do cloud recognition, and many others. Thank you very much for listening to the presentation, and if you have any questions or suggestions, feel free to get in contact us any way on Twitter or any other way you like. Bye.